Hello everyone, welcome back to Cloud Pedagogy. Thanks for joining me in today's session, which we are going to discuss Compute as a Service on AWS. Before that, we'll try to understand what are the servers. The first building block you need to host an application is a server. Servers oftentimes can handle hypertext transfer protocols, which are HTTP requests, and send responses to clients following the client-server model, though any API-based communication also falls under this model. A client being a person or a computer that sends a request, and a server handling the request is a computer or a collection of computers connected to the internet serving websites to internet users. So we'll see how the scenario without AWS Cloud. Every business needs raw compute capacity to run their applications. These applications could be web servers, batch jobs, databases, HR software, machine learning, or just about whatever you can think of. The time, money, and effort it takes to get up and running with on-premises computing resources is fairly high. When you own your own fleet of physical servers, you first have to do a bunch of research to see what types of servers you want to buy and how many you need to buy. Then you purchase that hardware upfront. You will wait multiple weeks or maybe months for the servers to be delivered. Then you take them to the data center space that you either rent or own, and you install them, rack them, and stack them and wire them all up. Then you make sure that the servers are secured, powered up, and ready to be used. Only then you can begin to host your applications on top of those servers. And the worst part is, once you buy these servers, you are stuck with them, whether you use them or not. It's not easy to just suddenly provision more physical compute capacity when you need it. And it's even harder to get your money back on servers that you no longer need. The most important thing is, it's impossible to get the time back. So then, how do you choose the right compute option? Following a compute as a service model is much easier to get started and easier to support operations over time. AWS took care of the hard part for you already as far as getting started goes. AWS already built and secured the data centers for you. AWS has already bought the servers, racked them and stacked them, and they are already online ready to be used. In this lesson, we show you how to launch the student directory application with Amazon EC2. We did not really talk about the details how EC2 works, what configurations exists for it, and we definitely didn't discuss any other compute options that exist on AWS. AWS has different services for different use cases. And Amazon EC2 is just one of the AWS services that is important to understand. We will be spending most of our time in these upcoming lessons exploring on EC2. That being said, though virtual machines like EC2 are great, there are other compute services out there too, like container services and serverless compute. You will learn about those other compute options and their use cases as well. Do not always assume that VMs are the default and correct answer. Sometimes it makes sense to architect the applications for serverless compute or containers from the start, depending on what you are building for and what you are optimizing for. Now we'll try to understand one of the compute option, which is Amazon EC2. Amazon EC2 is a web service that provides secure resizable compute capacity in the cloud. It allows you to provision virtual servers called EC2 instances. Although AWS uses the phrase web service to describe it, it doesn't mean that you are limited to running just web servers on your EC2 instances. It gives you a lot of flexibility and control in the cloud, and you can configure them to meet your needs. You can provision one or many EC2 instances easily. And at the end of the billing cycle, you only pay for what you use, either per second or per hour, depending on the type of the instance. When you no longer need an instance, you can terminate or stop the instance and you will stop incurring charges. Not all servers are the same, and you're probably looking to run a specific type of operating system on your EC2 instance. AWS supports a range of operating systems including Linux, Mac OS, Windows, and many more. To select the operating system for your server, you must choose Amazon Machine Image, or we can also call AMI. The AMI contains information about how you want your instance to be configured, including the operating system, possible applications to be pre-installed on that instance upon launch, and other configurations as well. You can launch one or many instances from a single AMI, which would create multiple instances that all have the same configurations. Some AMIs are provided by AWS, whereas others are provided by the community and can be found using the AWS Marketplace. You can create and manage these instances through the AWS Management Console, the AWS Command Line Interface, or AWS Software Development Kits, or through automation tools and infrastructure orchestration services. For example, when launching an EC2 instance, the first setting you configure is which operating system you want by selecting an Amazon Machine Image. Amazon Linux 2 is the AMI we selected when we launched our student directory application. This AMI is provided by AWS and it is essentially a pre-built EC2 optimized Linux image that has long-term support provided by AWS. At this point of time, you may get a doubt. What is the relationship between AMIs and EC2 instances? EC2 instances are live instantiations of what is defined in an AMI, much like a cake is a live instantiation of a cake recipe. If you are familiar with software development, you can also see this kind of relationship between a class and an object. A class is something you model and define, while an object is something you interact with. In this case, the AMI is how you model and define your instance, while the EC2 instance is the entity you interact with, where you can install your web server and serve your content to the users. When you launch a new instance, AWS allocates a virtual machine that runs on a hypervisor. Then the AMI you selected is copied to the root device volume, which contains the image used to boot the volume. In the end, you get a server you can connect to and install packages and any additional software. In this case, you install a web server along with the properly configured source code of your student directory application. One advantage of using AMI is that they are reusable. If you wanted to create a second EC2 instance with the same configurations, how can you easily do that? One option is to go through the entire instance creation and configuration process and try to match your settings to the first instance. However, this is time consuming and leaves room for human error. The second better option is to create an AMI from your running instance and use this AMI to start a new instance. This way, your new instance will have all the same configurations as your current instance because the configurations set in the AMIs are the same. Beyond the properties determined by the AMI, you can also configure the instance type and size, which correspond to the amount of compute, memory, and network capabilities available per instance. Different applications have different hardware requirements, and choosing the instance type for your application gives you the ability to pick the hardware that it runs on. It's also really nice that you have a wide variety of choices for your instance types, as it's hard to achieve the same level of variety with on-premises resources. The instance type you choose are grouped for use cases like compute optimized, memory optimized, storage optimized, and many more. There is a list of instance types. that you can find in AWS documentation. For example, the G instance family are optimized for graphics intensive applications, which would work best for use cases like 3D visualization or video encoding. Whereas the M5 general purpose EC2 instance family provides a balance of resources and are great for applications that use these resources in equal proportions like web servers, our student directory application for example, or things like code repositories. When you are launching an EC2 instance, you will see something like t3.medium.a1.large. When selecting an instance type and size, the T3 or A1 is the instance family that determines the blend of the hardware capabilities. Then there is the dot. Then there is the size like small, medium, large. It goes down to nano and up to many extra large sizes depending on the instance type. The great thing about this type of selection existing right at your fingertips is that you are no longer locked into hardware decisions upfront. You can choose an initial EC2 instance type, evaluate its performance for your specific use case, and then later you can change to a different type that is better suited for your application. EC2 is also resizable with a few clicks in the console or can be done programmatically through an API calls. All these configurations being available to you via API enables you to embrace change over time easily as your workloads mature and change. So alright, we understand that virtual machines are cool and totally not new. So how does this impact your business? The important thing is this. The flexible and low-cost nature of EC2 instances as well as the ease of provisioning servers allows for programmers and businesses to innovate more quickly by spinning up servers for a short amount of time to run experiments and find optimal configurations for your applications. EC2 offers a wide variety of hardware options to choose from. So you can optimize for your solutions by selecting the right EC2 instance type for your application. And then you can optimize even further by right sizing the resource or selecting an instance size that is appropriate for your application and not over provisioning like is often done on premises. This type of optimization is hard to achieve on your own because with traditional on-premises deployments, you are working with hardware constraints that simply don't exist in the same way in the cloud. The ability to adapt changes and choose really specific configurations for your virtual machines all through a couple of API calls is very powerful. And really, EC2 is just the beginning of that story. I hope you understand the concept of EC2, which is a compute as a service. When you are ready, please join me in my next lecture. Until then, see you. Take care.